Am I live now?
Yes, you are.
I am. Okay. We'll start the session then. Welcome everyone to this session. The session is called Planning the Urban Water Energy Food Nexus. Do you think that most of the participants are here already, or should we wait for another couple of minutes?
I don't know, whatever you want.
Well, how many people do we have right now?
Just here in the Zoom or in the platform?
Well, both, I guess.
In Zoom, just you and Rex.
Okay. And in the platform?
Let me check. Well, we can't really count the people that are watching us on the platform now.
Okay, okay. So what do you think? Should I start or should we wait?
Yeah, just start.
Okay, thank you
There's
very much.
always a reply anyway.
Okay, perfect. So welcome to this training session called the Planning the Urban Water Energy Food Nexus. I'm Dr. Daphne Gondeliker. I'm a researcher at the Chair of Urban Water Systems Engineering at the Technical University of Munich in Germany, TUM. I'm an urban planner and an architect by training, and I now work in the environmental engineering department. And the aim of today's training session is to talk about what I call integrated urban planning. That is how we can do urban planning across different sectors of cities and by incorporating different stakeholders and actors into the process. So the aim of the session is to raise awareness on the co-benefits of using integrated urban planning as an approach, to provide some information about interlinkages between environmental and social issues that can be leveraged on in order to create more sustainable urban development. And particularly, we like to point out some potential synergy opportunities between climate change mitigation and adaptation approaches and measures. In the session, we'll provide some tools in order to facilitate a dialogue on how to develop innovative integrated urban planning models. And also, the session is very short, but we're going to hint at how we can do a transdisciplinary discussion in order to talk about integrated urban planning. So this is how the session is structured. We'll have a brief introduction right now for another 10 minutes or so, in which I will explain the Nexus approach and how we use it at TUM. And then we'll go into breakout groups in order to start working on developing our own Nexus synergy opportunities. Then we'll have some brief presentations from the groups, depending on how many people we are by then. And then we'll have some more input from me about potential Nexus solutions. I will present some good practice examples from around the world that we know of, that where the Nexus approach is being applied. Then again, in breakout groups, we'll go into designing such Nexus solutions using case study cities, and then again we'll have presentations on those. So the background to this training is a cityscape that we all know well. We know that economic growth is driving cities to consume too many resources, or more resources than are available, which in turn is driving climate change and environmental degradation, and that in turn often causes urban environments that are unfit for humans to live in, as we can see in these pictures. Of course, this is a very extreme form of what these urban environments can look like, but also in urban environments in Europe, for example, have their inherent issues in that cities are consuming too many resources. It's just that we tend to displace these externalities. And so the environmental effect is not so visible in a city like Munich. However, the causes for these cities to use so many resources are the same. It's our economic growth system that is driving the huge, large-scale consumption that we have of resources like water, energy, and food, and other resources. And that's why the challenges that we face are systemic, and it's worthwhile thinking about these patterns of urbanization and where we can intervene to change them. So in order for our cities to be able to decarbonize, we have to look at how we can conserve natural resources like energy and water, and even better, how we can reshape our cities to not only decarbonize, which is the minimum that we need to tackle climate change, but to make them able to rejuvenate the environmental damage that has already been caused. So cities can also be engines of environmental rejuvenation because they have a lot of resources. And here's where integrated urban planning is a huge opportunity to make cities dynamic rejuvenation engines, because many different sectors are at play, and many resources are in place, and many stakeholders are as well. So the water, energy, food nexus approach is one way to address integrated urban planning. It came up out of a discourse of how to tackle urban planning complexity, and the water, energy, food nexus approach crystallized three sectors that are essential basically to human survival, water, energy, and food, and tries to work with those sectors as a basis for sustainable urban development. So the approach, which was coined by Professor Hoff from the Stockholm Environmental Institute in 2011, highlights that there are many interlinkages, particularly between the sectors water, energy, and food. For example, it takes a lot of energy to supply fresh water and also to remove or treat wastewater, and there is a lot of water that is needed to produce energy and also food and other interlinkages. The approach does not, however, preclude other sectors. So other relevant sectors, of course, can also be tied in, like transportation, solid waste management. Of course, we can't discuss about food without land and so on. It's just a way of making that urban complexity more manageable by starting with the key sectors. The approach also underlines that no integrated urban planning can take place without a governance, a responsible governance approach. It takes a lot of stakeholders to talk to each other to be able to implement this type of integrated urban planning. The approach also underlines that water is really a key element in the overall sustainability approach that is needed for cities. And we also need a new perception of water as a very valuable resource without we cannot survive. So when we look at cities as they are planned at the moment, usually cities are still planned in a very conventional way using mostly linear urban infrastructure systems. For example, when we look at water infrastructure, water is sourced from outside of cities, often brought over long distances, then consumed within cities, and then wastewater is collected in a centralized treatment system and transported to the city limit, where it is treated and, in the best case, given back to the environment in a clean form in order to be reabsorbed and then sourced again from long distances. And that process is very water intensive because these systems are huge. They have to cover whole cities. A city like Munich has 2 or 3 centralized wastewater treatment plants. And transporting the water over such long distances, besides needing a lot of water to flush so that the system doesn't clog, also uses a lot of energy. And also the wastewater treatment process is very energy intensive. So when we look at that, we realize that a lot of the resources that we're using are brought into cities from outside. They're consumed and then the externalities get exported, so to say. But there are very few resources that are harvested at city level, even though they may already be here. So for example, wastewater is accruing in cities, but we're not using it systematically. We just try and get rid of it. Also, rain falls on our heads, especially in Munich. A lot of rain falls on our heads, but we try to avoid flooding. We don't use that rainwater. We don't systematically use biological waste or excess heat from industries or plastics and so on. So there are many opportunities to make these city systems more circular, closing different resource loops. And for this, there are many alternative technology options available, but the implementation is lagging seriously behind, and these conventional linear urban infrastructure systems keep being implemented for various reasons. So the first step in trying to implement alternatives is to develop what we call a synergistic way of thinking between sectors. So this is what we do in our group. Our group and at TUM or TUM is called the Nexus Lab. We're a small group inside the Environmental Engineering Master's Program. We have a dedicated field of study since 2016 called the Water Energy Food Nexus, which I coordinate together with a colleague. And the research focus of our lab is looking at water reclamation with resource recovery. So that is, what can we do with the wastewater in cities and metropolitan areas in particular, including the energy and nutrients that can be recovered from them, which we see as key nexus synergy opportunities. So we look at the three sectors together with other relevant sectors like transportation and waste management, and in parallel, the three sustainability pillars, so the society, economics, and environment, to see how they fit together. We work with case study cities to try and facilitate participatory multi-stakeholder processes, particularly in some Indian cities. And we have 2 cities in Africa and also in Germany going on. We have about 25 master theses and study projects running at one time and 3 doctoral candidates, as well as a lecture course where we have about 75 students enrolled per semester with 6 credits. So this is, to boil it down in one slide, our approach to say that there are different sectors in the city, and we try and exercise this synergistic thinking across sectors by defining a range of sectors. They could be different as well, but we call them water, transportation, food, energy, solid waste, land, air, and there could be others. And then we try and do something like a SWOT analysis for a case study city, where we look at what are the assets of a city, and then what are the issues that the city is facing, and how can they be brought together across sectors in order to create key synergy opportunities. So one example could be a city where there's a large amount of sewage available, which is not being used. So it is an asset. It's also an issue maybe, but it's also an asset because it's a valuable resource. So Munich is a good example. Then maybe in transportation, there's a problem with air pollution in Munich. So we have a lack of clean fuels for public transport, for example. So that sewage could theoretically be used to generate such bioenergy. That's one way of linking the water and the transportation sector. And by creating such bioenergy, we can even create another valuable co-product, which is organic fertilizer. So we have a synergy opportunity here in the energy sector, which is biogas and organic fertilizer, which again, even is linked to another sector, the land sector, because this can be used, for example, to fertilize urban agriculture. Another example could be that there's a lot of bio-waste which is not being harvested, or which is also the case in our city, Munich. There may be a lack of fresh vegetables available in the city center. So having organic vegetables in Munich is pretty expensive, for example, for elderly people who have a low income or low income groups, and also for everyone else, organic vegetables are expensive. So there's an opportunity here also for urban agriculture to locally grow food. So this is the kind of exercise that I would like to do with you in this session. And what I had prepared was a 15-minute breakout session in 5 groups, where each group would brainstorm on key potentials across sectors and devise synergy opportunities from them. But now I can see that we have only 5 people in the Zoom group, so I'm not quite sure how we're going to do this. Maybe tech support, could you advise? Can the people who are in the live stream, they can't join us, can they?
Excuse me?
So how many, we have 5 participants now, am I seeing that correctly?
Yeah, you and 2 others, just 3.
Just 3, okay.
Yeah.
So how should we do this? So from the live stream, people can't join, can they?
from the live stream, they can join this Zoom link by just pressing join us.
Okay, so in that case, I would like to invite people from the live stream to join us if you would like to do this exercise with us.
You want them to join here?
Yes, if that's possible.
Yeah, of course it is.
Oh, great. So we'll wait for a couple of minutes to see how many people we can get to join. And for the participants who are already here, you're welcome to switch on your videos and your audio, and we can start the discussion. If you have any questions about the Nexus approach, then you're very welcome to put any questions. Do you think we're going to get any more people to join us? Hello? Hello? Tech support?
Yes,
Hi, sorry. Do you think anybody is going to join us or?
I don't know. I really have no idea.
Okay, because the two participants who are in this session are also not responding, so it's kind of difficult to do breakout groups.
Yeah, I get it.
So what should we do? Should I just continue?
Yeah, I think so.
Okay, that's too bad. And this is so difficult to do online. I really look forward to having in-person conferences again. The whole exercise gets more interesting and more fun.
Yeah, exactly.
Okay, so I think then in that case, we'll just go on and explain some of the existing Nexus solutions that we've compiled from around the world. So there are many cities already implementing a kind of Nexus approach. It's just that mostly they are doing it implicitly and not explicitly, but in any case, it's a way of implementing integrated urban planning, which can mean planning across different sectors, but it can also mean planning across different administrative levels or across different spatial scales, or also involving different types of actors and stakeholders. And to the participants who can hear me, who are here, you're welcome to interrupt me anytime as well, and ask questions, because it would be really nice to have more of an interactive session of some sort, if you like. So I compiled a few examples here. The first one that I would like to talk about is the city of Guadalajara in Mexico, which has taken an integrated approach, particularly looking at infrastructure planning. So this city had a lot of issues with traffic congestion, and also the city center was difficult to access by the local population. There were issues with violence or crime, and also it was not very beautiful. It was very unfriendly to pedestrians. So the city decided that they wanted to do something about it and to create a more livable city. The main reason being that they wanted to keep some industries that are in Guadalajara in place. They didn't want them to leave. And obviously these industries employees didn't want to live in a city that was not safe and not beautiful and even had a lot of air pollution. But if you want to transform a city, obviously that costs a lot of money. So the approach that this city took was to work with the industry partners to think jointly about how the city could be improved. So in the case of the Guadalajara city, they approached the World Business Council for Sustainable Development, which is an association of industry companies all over the world with about 200 members, and it's led by these companies' CEOs. And they got together and had a brainstorm and decided that they would take a focus on improving infrastructure in the city, and particularly transportation infrastructure. So one of the leading companies that got behind this initiative was Siemens, which also has a dedicated mobility and integrated planning development branch. So they've decided to think across different sectors and trying to fuse transportation with a sustainable urban development approach. So they implemented particularly a transit-orientated public transportation system, where public transportation was implemented in such a way that new housing developments could be allocated close to it, so that less car ownership became feasible, so that people became more able to use public transportation in the right places to get to work. And they also implemented large-scale pedestrian and cycling network. And all of this was geared towards, of course, reducing traffic congestion, also air pollution, and making the city more beautiful and livable. So a lot of green infrastructure was also added. And in total, made a huge difference. And obviously these companies also were able to contribute a sizable amount of funding, which usually is difficult for local governments to procure. The next example that I would like to show is the city of Rajkot in India. This city is a medium-sized city in the northwest in a semi-arid location in Gujarat. So here, the city expanded very quickly in the last decades, and with it came a lot of haphazard urban development, a lot of traffic congestion, all the typical problems that cities face that transform very rapidly. And in the case of this city, it was compounded by the fact that Rajkot has very little water. So the city is facing the issue of sinking groundwater levels, where the water demand is just higher than what can the groundwater sources can provide. And it's very dry, particularly in summers. There are water shortages. So this approach that this city took was firstly to apply for some national level funding. So the city became one of India's lighthouse projects for the Smart City program, which in the first instance selected 100 smart cities to join the program and gave them some seed funding in order to develop their urban planning approaches in a more sustainable manner. In India, the word smart city has a very different connotation to what it has in Europe. In Europe, the smart city approach is very much linked to the digital transformation. So it's all about smart metering, putting sensors everywhere, collecting big data in order to be able to collate all the data and make cities as efficient as possible. In the case of India, however, when Prime Minister Modi launched the program, Smart City Initiative, or mission, it's called Smart City Mission, pardon me, he said smart should be something that works in the first line. Let's go back to what that word actually means. It's something that works in the context of a problem that it's trying to solve. And when we think about urban development in India, he said, the first important thing to think about is water management, because water is the essence of humans, so it is needed for human survival in the first instance. And of course, it can be smart also in the sense of using digital tools. But in the first instance, we need a clever solution that works to solve the problem. So the city of Rajkot decided to use the seed funding to approach the issue as follows. They used a tool called the Global Protocol for Community Scale Greenhouse Gas Emission Inventories in order to find out which sectors in the cities were causing most of the greenhouse gas emissions. So they wanted to know if they would reduce the carbon footprint or the greenhouse gas emissions footprint of their city, where to start in such a complex setting with so many issues to look at. And this tool identified transportation, water supply, wastewater treatment, solid waste management, and street lighting systems as the key emitting sectors. So those are the ones the city decided to start with. And the next thing that they did before doing anything was to start up a huge digital transformation for their urban administration. So they digitized everything that before had been running on paper. And that in itself freed up a lot of capacity that the city before didn't have to tackle new projects or to look at a more holistic approach to urban planning. So that gave civil servants more capacity, and using that capacity, the city of Rajkot next decided to draw in their citizens in a large scale initiative as well. So they launched a huge social media campaign over various channels, using all kinds of apps to collect opinions from citizens about how the city should develop, which development paths would be most favorable, most suitable. So to get citizens buy-in into innovative approaches from the beginning, and also to collect ideas, basically, because that's a huge pool of people who have ideas about what they could also help with. So there was TV advertisements, there were radio broadcasts, there were public events, there were, people could drop by with a piece of paper and give their opinions. So a lot of work happened there, and that set a very good stage to be able to launch the next part of the program, which the city of Rajkot implemented, which is called the Smart Society Scheme. So there they also drew in people by using this wording. They called it the Smart Society to say that our society is smart, and also it can get smarter by implementing a scheme that uses smart solutions. And everybody becomes part of this initiative, which also they were involved in starting up. So again, using the grant that the city got from the national level, from the smart city missions. The city of Rajkot designated 100 existing residential areas per year for upgrade. So they picked these housing societies, which in India basically are these communal blocks with maybe somewhere between 50 and 200 households in them, which are managed by one entity, and they have a community which can basically co-manage the infrastructure. And they gave them some seed funding in order to implement some innovative infrastructures. So one of the things that was implemented was rainwater harvesting and also a decentralized treatment of wastewater. And in fact, several cities in India have been trying to implement ordinances to make rainwater harvesting mandatory. It was an idea, as far as I know, that started up in the city of Chennai, but not all cities have been successful in implementing this. But in Rajkot, it was very successful, partly due to this program. So this rainwater harvesting was implemented on the roofs of these societies, which are typically flat. And just by putting rainwater harvesting on these buildings, the city was able to bring up the groundwater levels, which were dangerously low, significantly, so that now they have reached sustainable levels and the city can manage them a lot more efficiently. And that in itself has taken a lot of stress off the water supply, which had to be sourced from far away. Now, again, it can be sourced more locally simply by using rain, which does fall on Rajkot, just not all the time, and storing it in the groundwater aquifer, which is also already in place. And the second initiative, the decentralized treatment of wastewater, also took a lot of pressure off the local government to have to remove wastewater from these housing societies, which in any case, in a city like Rajkot is a big challenge. These cities have expanded so rapidly that infrastructure systems can struggle to keep up, and often the adequate management of wastewater is a big challenge. So by having these blocks, inner city blocks, deal with their own wastewater in a decentralized way, took a lot of pressure off the wastewater management system and freed up its capacities to deal with the wastewater in other parts of the cities. And all in all, this water, which is being reused on location, so the rainwater that is harvested, the decentralized treatment of the wastewater, which can be reused for toilet flushing. So typically that means that the water from toilets is separated from the water which comes from kitchen sinks or from the showers. And this water that comes from showers and kitchen sinks is relatively easy to treat up to a level so that it can be reused for non-potable uses. So not for drinking water, but for other uses like flushing the toilet or for irrigating the garden patch, or maybe for washing cars or for spraying pavements and so on. This is perfectly suitable, very safe, human health-wise. So that's relatively easy. So these initiatives took a lot of pressure off the water supply side as well, and with it, the energy demand, because there are now a significant amount of wastewater that doesn't have to be treated in centralized or conveyed and treated in centralized sewage treatment plants. The city also implemented another ordinance whereby basically the use of potable water from non-potable uses was simply forbidden, come with a big fine, as well as some incentives. For example, it gives tax rebates to buildings which are built new with rainwater harvesting and water recycling in place, for example, or property tax rebates. And it even made use of recycled water for toilet flushing a precondition for building approval for new buildings a few years ago. Also in the Smart Society scheme, it's been piloted to use wastewater to generate bioenergy. So biogas is created from sewage, which also can generate a significant amount of energy, which can also save households a lot of cost in theory. So this is at the pilot scale at the moment, but it's planned to scale it up. And this can also take pressure off the local service providers that are trying to provide electricity. And biogas can also be used for cooking, which is a typical way of cooking in India. So there is a huge potential to use these resources that are in place for local water and energy demands, and link to it also food demands, because again, from this biogas generation, a co-product that we also mentioned before, is organic fertilizer, which can be used for urban agriculture, it can be sold, it can be used for agriculture in the peri-urban and rural areas as well, thereby linking urban and rural development in a symbiotic way. So if you're wondering, I'm drawing out this talk now a little bit. I was planning to zoom through this so that we have more time for breakout groups, but since we're not having breakout groups, I'm just going to this in more depth. If you would like to have a discussion, then please just speak up anytime. So here's another city that we like to showcase as a Nexus good practice. It's the city of Växjö in Sweden. It's a very small city comparatively, only has about 100,000 inhabitants. But this city already very early in the 1980s formed a vision saying that energy use needs to decrease and that energy should come from renewable energies 100%. So they've been following this vision for decades already. And in the case of Växjö, they linked it to the concept of a circular economy. So at some point in the first oil crisis, they discovered that the city is using a huge amount of its revenues to buy oil. And one big reason for that is because it's very cold in Sweden in the winter. So a lot of that oil is used for heating. But then it occurred to the city of Växjö that they're also located in a forest, and it's got its own wood chip industry. So wood is used for all kinds of construction materials and so on, and a lot of wood chips accrue, which was basically a waste material before that. But the city decided to implement a waste to energy plant. And with this, they were able to become almost autonomous in terms of their heating fuel. So I think it's, yeah, here it says about 90% of the heating now comes from renewable energy. And that led to a very significant decrease in CO2 emissions in Växjö. So the emissions from heating were reduced by 83%, which is, of course, extremely significant. But the biggest selling point of Växjö was how they translated that into their circular economy concept. So when they did the maths, after having spent the initial infrastructure, the capital investment and the operation investment and so on, they found that the overall economic growth rate in Växjö had increased by 73%, simply because not so much money was being spent on buying oil anymore. So that was a big surprise, I think, and a great surprise for everyone. And now the city of Växjö is trying to use that model to change policies at a national level and show how resources available locally can be leveraged on in order to create resources that can cover a very significant amount of the demand. What they also did was to link different sectors by, for example, using also sewage together with organic waste, which is collected from the households, making it very easy for households to participate. And this organic waste, together with wastewater, when it's co-digested, is a very good source of energy. A lot of fat also from restaurants or other organic wastes can be used, for example, from breweries or from dairy farms or from different other poultry farms or other animals. Farming can be mixed, and it's a source of biogas. And it also helps to capture greenhouse gas emissions that otherwise are let into the atmosphere. So, for example, methane is recovered, whereas in a sewage treatment plant, that would simply go to the atmosphere. So it has many co-benefits. And in the case of Växjö, what the local population is producing in terms of sewage mixed with the organic waste is enough to run the public transportation system. So that's a significant amount of clean fuel. And the city had to invest, obviously, in new buses, but it's a sustainable investment. So next, I'd like to come to two examples that we at TUM, in the Nexus lab at TUM, have been working on to explain how we apply the approach in our case study cities. And again, this is very short. I just compressed it onto one slide per case study because I thought that we would not have so much time. So forgive me for not showing more information. This is a city in the Indian Himalaya called Leh. It's the cultural capital of the Ladakh region in the state of Jammu and Kashmir. And this town also has grown very rapidly in the last decades. It started as a very small agricultural community in the early 1980s, which was basically self-sufficient in terms of its food supply. It was completely cut off also from the rest of India because Ladakh is on the border between Pakistan, China, and India. So it has a big military base, and it was not open to foreigners or tourists from India until in the early 1980s, the Indian government decided to open it up for tourism because it has a lot of very interesting and valuable cultural assets, being an ancient Tibetan kingdom, and the Buddhist culture is very much alive in Ladakh. So suddenly there was a huge influx of tourists. In 2019, before the COVID pandemic, there were around 300,000 tourists visiting Leh every year, which is a really sizable amount compared to the local population, which is only between 30 and 50,000 inhabitants. So because of that huge influx of tourists, and most of them come from mainland India, and of course also European and other American tourists from all over the world. Because of this huge influx of tourists, hundreds of hotels and guest houses have sprouted up in Leh, trying to cater to all of these visitors. And Ladakh is a semi-arid, high-altitude area, so it's about 3,500 meters above sea level. It hardly rains at all, except for occasional flash floods, and it gets extremely cold in winter, obviously, but it's very, very dry, also even if it snows. And the only source of water are glacial meltwaters, which feed aquifers such as below the Leh Valley, on top of which the town is built. And until the early 1980s, the population in Leh was using water very, very sparingly. So water is mainly used for agriculture, irrigation, And the water in this glacial melt streams that's feeding the groundwater aquifers was so clean that people drank from the streams. But once all these guest houses and hotels started opening up, they felt that it would be good to provide tourists the amount of water that they're used to using at home as well, in order to make Leh a more attractive tourist destination. So all of these hotels and guest houses implemented flush toilets and showers, where before that in Ladakh, people used only dry toilets and showers basically didn't exist. People used a bucket to take a bath. So this meant that suddenly in Leh, a lot more water is being used than before. And this water was being provided by the local government, by the Public Health Engineering Department. And the department soon discovered that they would not be able to provide enough water to cater to all of these hotels and guest houses and the amounts of water that they wanted to use. So a typical Ladakhi, before the influx of tourism, would be using, according to our survey, maybe 20 liters of water per day. And an average person in Munich today uses 135 liters of water per day, roughly. And what the Indian government guidelines say is that for a small town, the local government should try to provide about 60 to 70 liters of water per person per day. And according to our survey, again, a typical tourist in Leh would be using or aiming to use about 100 liters of water per day for showering and using flush toilets. So there are vast differences between the amount of water being used, and the local government was only able to provide water for 2 or 3 hours a day. The water has to be pumped from the Indus River aquifer, which is several kilometers away. Some of it is pumped from the groundwater below Leh. This is extremely energy intensive. All of it is managed using diesel pumps, which regularly have issues so that the water pumping is interrupted. And as a result, these guest houses and hotels found that they couldn't run their guest houses with so much water consumption based on public water supply. So they started digging their own bore wells into the groundwater aquifer below Leh and pumping out groundwater. And again, according to our survey, which we did, and we've been working in Leh for almost 10 years now already, the amount of water that is privately extracted through these private bore wells is about half of what the city is providing. So a very sizable amount is being pumped out, and this has been steadily increasing as well. So this groundwater extraction is not regulated in Leh, so concerns started coming up about the level of the groundwater and whether it was sustainable to keep pumping out groundwater from it in this way. And of course, where a lot of water is being used, also a lot of wastewater accrues. And the way it was being managed in Leh was that companies implemented septic tanks, and there it would be collected and regularly emptied. It's just that when the emptying was supposed to occur, it was found that most of the septic tanks were already empty, which basically meant that they weren't really sealed septic tanks, but they were soak pits where the water simply seeped into the groundwater, and the result in Leh, which we also were able to prove, was that the groundwater was severely contaminated, mainly by fecal coliforms. And since the groundwater is the source of drinking water in Leh, this means a very significant public health threat. So the city decided about 10 years back that some solution was urgently needed, and hired an international consulting company to come up with a solution. And the international consulting company said, well, the only solution that we have on hand is a centralized sewage system. So they drew up a plan for it and designed a system in which also, again, national government guidelines were incorporated. And according to national government guidelines, cities with a centralized sewage system in India need to provide per person 135 liters per day, because the system again has to be flushed so that it doesn't clog, and that's the amount of water that it takes. Also, this water was supposed to be, or it's now being built. This water will be collected in a centralized sewage treatment plant, from where it will be treated and released back to the Indus. So it goes back to the environment in a treated form. So basically, what we've been trying to do in Leh is to have a dialogue with the local government and various different stakeholders about the question whether it makes sense to implement this conventional linear infrastructure in a place like Leh, or if there are also alternatives to this. We've now reached the point where hopefully we'll go into the implementation of a pilot project at some point in the next couple of years to showcase what an alternative infrastructure solution could look like. So we've been arguing that providing twice as much water as the local government is supposed to be supplying at the moment will put a lot more pressure on the local government, on top of the fact that it will cause an even higher carbon footprint, because the pumping, extra pumping that will be needed to procure this water is significant. And at the same time, also putting out the question of whether it makes sense to use the same amount of water in a semi-arid, almost desert location as we use in Munich, or whether it could also be a strategy to advocate something like a water-saving tourist industry, which could be a unique selling point for Leh. I mean, there is no reason to think that that we need to behave the same way that we behave in one place in another place, where the environmental conditions are so obviously so completely different. So we've been trying to design an alternative decentralized option, pointing out that if instead of a centralized system, if we use decentralized systems, we'll need a lot less water to flush these systems. In a centralized system, with this per capita of 135 liters per day of water that's supposed to be used, about 40 liters of that is just needed to flush out the long pipes. So in theory, if we don't have those long pipes, we also don't need those 40 liters just for toilet flushing. This is drinking water that is being provided essentially to flush the toilet. So that's one way of saying we can reduce the amount of water that we're using. This will obviously, again, save a lot of pumping energy. So the city can just stay at the amount of water that it's trying to provide at the moment. If we have these decentralized systems and we collect this accruing wastewater in decentralized pockets, then also we have the water available at the place where we potentially can reuse it. So we can treat it in smaller treatment plants and reuse that water for non-potable uses, for example. For toilet flushing, it could be used. It could be used to irrigate urban agriculture. It could be used to feed the stream system. It can be used for greening, for the kitchen gardens, to plant flowers, to make the atmosphere in Leh generally nice and green, which has other co-benefits. For example, it can cool down in the summer. It does get quite hot. It can cool down, make the urban environment more pleasant. It can act against dust and ameliorate air pollution from the significant traffic in Leh and so on. So there are many potential co-benefits. And also, if these treatment plants are smaller, they can potentially also run on renewable energy. So this idea of creating biogas from sewage with organic waste can also be applied there in order to run these smaller treatment plants, or to generate bioenergy also for households or hotels and guest houses on location. In the centralized system, if we collect all of the water basically at the bottom of the hill and we want to reuse it for urban agriculture, we have to pump it back up the hill, which again would be a very significant energy consumption element. So Another co-benefit of doing this decentralized wastewater treatment is that we can also recover the organic fertilizer from human waste, which in essence is what the Ladakhi dry toilet was doing, or is still doing. And it's still being used as a source of organic agriculture by the local population. In a centralized sewage treatment plant, that practice would probably also quite literally go down the hill, and people would then rather tend to buy more chemical fertilizer, which has an impact on soil fertility. So this is our integrated approach that we have been advocating to the city of Leh with a lot of success, but it's been a very, very long process. And the stakeholder interaction exercise also is something that takes a lot of time and patience, and it's been a very interesting journey. Somewhere through the middle of that journey, our friends in India said, well, if it's such a great idea, why don't you try applying this water, energy, food nexus idea to your own city? So that's exactly what we did. We started up a case study in our city, Munich, and we started by looking at a central Munich district, the area where the university is located, actually. And as we can see in the GIS map, it's a very densely knit urban fabric with this block style development. Before the First and Second World War, the inner area of these blocks was supposed to be garden area and also maybe kitchen gardens. But after the Second World War in particularly, a lot of this area got built up by temporary housing and temporary structures, also for military occupation in Munich and so on. And a lot of these temporary structures then kind of just stayed there. And now most of them are parking areas or workshops, garage, and most of the area inside of these blocks is sealed up. So in a typical neighborhood, there is very little green area, and the result is that already now in Munich, with climate change, there are more hot days in the summer, there is less rain in the summer, and also in the nights it doesn't cool down as much. So already we're noticing in Munich that there's a significant public health risk from the urban heat island effect, which is a particular risk to the elderly and to young children. So the city has to find a way of dealing with it. And one way of dealing with the urban heat island effect is to increase the amount of green infrastructure in the city. Another thing that we know about Munich is that it has a centralized sewage system, which has been in place for over 100 years. And this centralized sewage system is so old now that it's in need of very large scale repairs. So there are some estimates that say that over the next 20 years or so, the city will have to invest around 500 million euros in order to keep the system up and running. And Munich is not alone in facing this challenge, but most Western cities have these very, very old centralized sewage systems in place that are now falling apart. Because they're so old and need to be repaired. And there are estimates also for the US, for example, where it's said that within the next decade or two, the US will have to invest around $1 trillion just to maintain the water supply and the wastewater management system the way it is, without any improvements or without new urban developments that need to be connected. It's just maintaining the status quo. So that means all the leaden pipes and all the issues that we've been hearing about would not be improved. So if we want to improve them as well, the budget would be a lot bigger. And it's difficult to grasp what $1 trillion means in terms of funding, but I think it's comparable to what the US spends on its military equipment. So it's a very sizable amount. So local government, like the city of Munich, really have to think about how they can finance that. And the fact is that they don't have the money to do this, so they have to come up with some kind of innovative ideas. At the same time, the city is very used to just maintaining the system as it is. They've been doing that for 100 years and it works very well. So they don't really see a need to change that. On top of that, in Munich, there is plenty of water available. It flows from the Alps in a pretty pristine and plentiful manner, so it hardly needs any treatment. It's not treated before drinking, and it doesn't need to be pumped because it just comes by gravity. So also the energy side of it is not as significant as maybe in some other cities like Sao Paulo, where we know that water has to be sourced from very far away with a very significant energy footprint. So there are many reasons why the city of Munich is not very much interested in thinking about alternative options. So we try to generate some numbers to make this alternative solution interesting to them. So the first thing that we said was, well, let's see if we open up some area for green infrastructure, what could we do with it? So we took this GIS map and we said, well, if we assume that in the future also the city of Munich will need less cars, there is definitely a trend to get rid of cars. At some point, hopefully there will be less of them, so we also need less parking. So what would happen if we get rid of these parking garages in the backyards and all the sealed parking spaces? How much space can we actually gain? So we made it very simple. We just removed all of the temporary structures. And of course, it's not as simple as that. I mean, we can't just use all of that area for urban agriculture. We also need space for other functions like playgrounds or pathways or other things. And we can't just take away people's workshops or parking spaces, of course. But it's just a theoretical exercise to see what resources are available in the city and what would come out of turning their functions around, giving them a different use, what kind of potentials they would have. So we looked at the ground spaces and we also looked at all the facades and said, well, the southwest facing facades can also be used for urban green infrastructure. And what would happen if we used all of those areas as well as the flat roofs and the roofs that are less than, I think it's 10% inclined, can also be used for urban agriculture. If we planted food on all of them, what would we get? And we started with a cabbage, a white cabbage, which is very popular in Munich. It's in Germany, generally in Bavaria, they turn it into sauerkraut, which is also very healthy food. It's pickled white cabbage. It contains a lot of vitamin C. And it happens to be the vegetable in Bavaria with the highest yield. So we planted that on all the horizontal surfaces. Then we thought, what would grow on the facades? We planted grapes. Grapes need hardly any watering under normal circumstances, and they grow very well, especially with the urban heat island effect, because that is the temperature that grapes like, which is also a new thing in Munich. It used to be too cold. But now, with climate change, we could, in theory, grow something like grapes, according to the agricultural ministry. And we also planted apple trees. And then we looked at how much yield we could get. And we weighed that against this neighborhood's population, which is about 50,000 people. And the World Health Organization recommendation, which says how much fresh fruit and vegetable every person should have per day. And we found that in our theoretical model, we would be able to supply about 66% of the demand for fruits and 250% of demand for vegetables for the local population. Now, obviously, we would all hate to eat white cabbage every day, and we also don't want to eat apples every day. And it would not make sense to probably grow all these vegetables in the inner city area. But again, it's just a thought exercise to see where we would get with our areas that are available. And urban agriculture has many other co-benefits. It can be a community project. It can bring together different types of people. It can generate these fruits and vegetables maybe at a lower cost than what it is in the organic supermarket, which is very expensive. So it can have many good other effects as well, on top of cooling down the microclimates, adding to the air quality and making the city generally more beautiful and more livable. On top of that, we can also, again, apply our idea of having our decentralized wastewater treatment infrastructure in place. In this case, we also said we could think about separating black water from toilets and the gray water from kitchens and bathrooms. We can recycle our gray water and use that to irrigate our urban infrastructure. And then we can use the black water with all of the organic waste that would also accrue. And in theory, we could meet a significant amount of the energy demand with that. So we estimated that about 20% of the household electricity demand could be covered if we do this. Biogas can be converted to electricity, or it can be also used for cooking, which is not so typical in Munich, but still it can also be a source of cooking energy. So these are our different options, and this biogas, this energy, these vegetables, all of them have a market value, a direct market value that can be used to weigh investment costs and weigh them against what it would cost to repair the centralized sewage system. And then it has also other benefits which are more difficult to valorize, but are at least understandable to most people. But of course, when a city official sees this, his first reaction will be to roll his eyes and to think this can never be implemented because it's just so complicated. And just imagine who we'd have to talk to. But maybe with climate change in a world where resources are getting more scarce, at some point there will be a tipping point where it becomes more feasible to think about such ways of generating resources locally. So basically, to conclude, this is our model where we try to show, using our various case studies, what the co-benefits of applying a water, energy, food nexus approach can be. So it can have many co-benefits. For example, it can help to conserve water and energy. It can be used to produce energy. It could also be argued that decentralized systems have shorter pipes and are therefore less prone to leakages, for example. It's easier to repair them. They may be more resilient to climate change-induced water scarcity or water uncertainty. Even with the COVID pandemic, decentralized systems can help us to track infection hotspots, for example, by measuring different parameters in the wastewater. So there can be many co-benefits to these decentralized systems, including also easier maintenance. And altogether, this approach can help to support the implementation of sustainable development goals in different ways, and generally promote water, energy, and food security by basically increasing the autonomy at the community scale of providing resources in terms of water and energy and food at a local level. This in turn also may empower local governments and therefore inspire a more responsible governance system in which these resources have a value and they can be co-managed also by the local population, potentially using infrastructure systems that are less difficult or high-tech to manage. There are many other options that are not so high-tech, quote unquote, that can be used to treat wastewater, that can be used to treat grey water, that can in theory be managed with some training, obviously, as opposed to some high-tech systems where you would need a company to run it, and often local governments are struggling to run these conventional sewage treatment plants, for example, and can't be done without the help of external consultants, which is all part of the business model, again, in order to further economic growth. Okay, I think that unfortunately, since we have so few participants and we couldn't have our interactive session that I thought we would be able to have, I'll just cut this session short 20 minutes ahead of time because I'm just talking to myself, which of course also is nice. I hope that this was interesting for you, the participants. To wrap up what I've been talking about so far, in our standing at the Nexus Lab at TUM, these challenges that cities are facing in order to tackle climate change are systemic. Even though cities around the globe look completely different, it's the same drivers that are shaping urban development and that are shaping our cities so that they use more resources than are available in the region. The economic system continues to drive the implementation of very resource-intensive linear infrastructure systems. And in order to tackle that, it helps us to take on this synergistic thinking that we've been talking about for the last 1.5 hours. And there are many alternative technology options available. It's just that most of them are not commonly been put into practice yet, but this is coming, so it's a very exciting time for us. And applying the Nexus approach is one way to facilitate this idea of synergistic thinking and integrated urban planning. So thank you very much for joining. It was a real honor to have this session at the Innovate for Cities conference. My email address is below, and this is our website, and I would like to invite you to take a look at what we're doing there and get in touch if you're interested in our projects or our programs. And just because I skimmed this earlier, I would also like to point out that we have this documentary film, which also explains our approach, and it can be watched for free online on this link. So thank you very much. Thank you very much, Rax, for the nice comments. Thank you very much, Tech Support, for the great help. And have a lovely day. Thank you. Goodbye.
Bye.
I didn't even have my video on. I'm sorry, you should have pointed that out. Okay, thank you. So yeah, too bad.